just about guarantee that on the Year 12 Methods exam, one of the questions you do will be answered via, or need to be answered via, a tree diagram. So tree diagrams can be used to list the sample space for multiple event experiments, okay? And that's for events greater than 2, or 2 is fine. But remember that in the previous topic, we did lattice diagrams, which need 2 events, can't do more than it. Tree diagrams can do infinitely many. The branches for each stage have a probability value which depend on whether a selection is made with or without replacement. We'll go into that later. All possible outcome sample spaces found at the end of a completed branch by basically putting together the letters for that event. The probability of each possible outcome in the sample space is obtained by multiplying those probabilities together. All right, let's get stuck into an example. So when you do it and when you set it up, make sure you identify and name each stage of the event. So if we're doing tossing a coin twice, the event stage 1 and 2 will be represented by toss 1 or toss 2. And the branches can be H or T, or H or not H is another way of doing it. Rolling a dice is another one, randomly taking a red, blue, white lolly out of a bag. So pick 1, pick 2, pick 3, where the possible outcomes is what you can get. Well, let's have a look at this. So tossing a coin twice, we've got a 2-stage experiment. So what we can get, first of all, is a head or a tail. So let's go a half and a half, 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 half. So the sample space can be found by just combining these two together. So head followed by a head, head followed by a tail, tail followed by a head, tail followed by a tail. Right, so what's the probability there? So we've got a half times a half, that's a quarter. Half times a half is a quarter, a quarter, a quarter. Now notice here we've got 4 quarters equals 1, and that's really important that our probability ends up at 1. All right, so let's have a look at this one here. What we've got is a bag contains 5 blue and 3 white marbles, and 2 marbles are selected without replacement. Draw the tree. Okay, so what we've got here is we've got blue and white. All right, we're going to note that there's 5 blue and 3 white, so that blue is 5 in 8 and white is 3 in 8. So this is stage 1. Okay, so we'll call that like pick 1. All right, now pick 2, we can get a blue or a white. Blue or a white. Okay, so what's the chances of getting a blue? Well, we're going to note that this is without replacement, i.e. a marble has been selected and it's not chucked into the bag. Right, so if we've picked a blue, what that means that originally there was, this is the state of play, we had 5 blue marbles and 3 white. If we've picked the blue first on pick 1, what that means is that there's 4 blues left out of a total of 7 marbles now. What are we getting if we get a white? Well, that's going to be the 3 white marbles out of the 7. All right, now down here, what we've got is a scenario where the white was selected first. So what we would do is put that one back in and select a white first of all. All right, now what are the chances of getting a blue? Well, there's 5 of them in the bag, of which there's 7 in total. What are the chances of getting a white? Well, we've got 2 whites left over, total of 7 marbles. All right, now let's represent our sample space. We can get a blue and a blue, blue, white, white, blue, white, white. What are my chances of this one here? Well, we're going to say that that's 20 on 7 times 8 is 56. Ooh, 5 8s, 15 over 7 8s are 56. 15 on 56 and 6 on 56. Now, I know I've talked about simplifying our probabilities, but we're actually going to leave these ones like this. Now, the tree diagram usually is just a tool to answer questions down here, not a question itself. Okay, so note that these probabilities here, we're going to leave them as their in unsimplified form because that makes them easier to use, and I'll explain why in a sec. All right, find the probability of selecting blue marble followed by a white marble. BW. So that's that particular outcome there. That's going to be 15 in 56, which is, yeah, simplified. Right, 2 blue marbles. So that's a blue and a blue. That's that one there. So it's 20 out of 56. 10 out of 25, 28. 5 out of, goodness girls, 10, 19, 19. Ooh, no, it's not 19. 14. 5 in 14. All right. I can do fractions. Just going to write that a little bit better. 5 out of 14. All right. At least one white marble. So one white marble means white, white. That's at least one. White, blue, or blue, white. All of these three cases is at least one white marble. But if that's what we're looking for, why don't we actually go, well, if I'm looking for all of these put together, there's two ways of doing it. So we'll just do it this way here. So I'm going to do 1 take away the chances of getting a blue blue, okay, which is 56 out of 56 take away 20 out of 56, which is 36 out of 56, which is 18 out of, I have this before, 28, which is 9 out of 14. So what I've done is basically removed the blue blue case. It would have been pretty easy in this case to add 15 and 15, which is 30, plus another 6, which is 36, and get straight to this point here. In fact, in this case, doing not it is probably harder than doing the addition of those three. Bag contains 2 red marbles, 4 green marbles, and 2 blue marbles. 3 marbles are chosen from the bag without replacement. How many outcomes are possible? All right, so what we can get is a red, green, and a blue. Red, green, blue, red, green, blue, red, green, blue. And then the same thing there. So we're going to get red, green, blue, red, green, blue. So it looks like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lots of 3 possible outcomes, 27 outcomes. And there is it there. But wait. Okay. Now we're going to note here that what is the case is we've got 3 red marbles, 4 green marbles, and 2 blue marbles. Now what we're actually going to have to do is look at what outcomes are actually possible. Now, if we've got 2 red marbles, if I pick a red followed by a red, what I can't get is the outcome red, red, red. That's not going to be possible, okay? I can get red, red, what's next, green and blue. So that one's a possibility. But this event here is not going to happen because I've picked a red one and I've picked a red one. I can't get a third red because only 2 red marbles are in the bag. So actually, it's going to be 26 possible outcomes. Now, the implications of the 2 blue marbles are exactly the same. I can get a blue followed by a blue, but I can't get that third blue. That's not going to happen. So what we've got to do is also remove one more, and actually the answer is 25, okay? It was on last year's probability test and it was done pretty poorly. All right, oh, this one's hard. Okay, so let's have a look at this problem here. As part of her job, Rosemary may receive phone calls. Over time, she knows that the probability of receiving X number of phone calls is as follows. So 0 phone calls in a day is, there's a 20% chance of that. 1 phone call, 20%. 2 phone calls, it's 50%. 3 phone calls, 10%. What's the probability that Rosemary receives only 1 telephone call on each of the 3 consecutive days? So she can get 0, 1, 2, or 3. This one here is 0.2, 0.2, 0.2, 0.5 rather, and I want to write 0.2, 0.1. Let's try that. All right, so that's like day 1. Then it'll be like 4 outcomes for day 2 and another 4 outcomes for day 3. Hopefully you can see that drawing the full tree diagram is going to be really cumbersome, like it's going to be massive. And I don't really want to do that. So what I've got to think about is we're going to get the event that we're talking about. What's the probability that she receives only 1 telephone call on each of the 3 days? So that's 1, followed by a 1, which is 0.2, followed by a 1, which is also 0.2. So in fact, that's going to be 0.2. Well, let's do it. 0.2 times 0.2 times 0.2, okay, or 0.2 cubed. All right, now how do you cube a decimal? Well, the answer is you don't. All right, what we're going to do is convert this to a fraction, which is 2/10 cubed, which is 1/5 cubed. Now, when we cube this fraction here, we're going to raise 1 to the 3, which is 1, and 5 to the power of 3. So that's 1 over 5 to the 3, which is 1 over. Now, 5 5s are 25. 25 times 5 is 125. So our answer is the chance of her receiving only 1 telephone call on each of the 3 consecutive days is 1 in 125. All right, now let's have a look at this last question here. Rosemary receives telephone calls on both Monday and Tuesday. What is the probability that Rosemary receives a total of 4 calls over these 2 days? All right, so we've got 2 days to contend with now. And so basically the scenario looks as follows. She could get 1 phone call on Monday. So this is Monday here, and Tuesday is 3 phone calls. She could get 2 phone calls on Monday and 2 phone calls on Tuesday. That equals 4. That equals 4. And she could get 3 phone calls on Monday, 1 phone call on Tuesday. And I think that they're the only ways I can make 4 phone calls. Yes. All right, so let's work out these probabilities. So 1 and 3 is going to be, so in the tree diagram, we'd be like getting a 1, which is 0.2, and a 3 in the tree, which is 0.1. So this one here is going to be made by doing 0.2 times 0.1. Now what's that? That's 2/10 times 1/10. That's equal to 2/100. All right, a 2 and a 2. That's going to be 0.5 times 0.5. Why? Because in the tree diagram we'd have a 2, which is 0.5, followed by a 2, which is 0.5. 5 over 10 times 5 over 10 is 25 on 100. 3 and a 1 is just going to be the reverse of this one here. So that's going to be 0.1 times 0.2, which is 2 on 100. So the answer looks good to be 29 over 100 when I add these together. There's one problem. Okay, now what is the problem? What we know is she did receive calls on Monday and Tuesday. That happened. That absolutely happened. Rosemary receives telephone calls on Monday and Tuesday. Now, what does that mean? That there's something that I know didn't happen in this table here. I know that she didn't get no calls. Okay, so I know for a fact that the chance of getting a phone call on the first day, okay, what's going to happen is that our sample space is going to reduce, okay? Or this thing here, it's actually not out of 100, it's a smaller sample space because I know that the 0 didn't happen. So what I'm going to do is work out what the probability is going to be out of. And the way I'm going to do that is I'm going to note that on Monday, the chance of her getting a phone call is actually going to narrow down to these amounts here, which is 0.2, 0.5, and 0.1. That's 0.8 in total. All right, so then on Monday and Tuesday, we've got a 0.8 and a 0.8, which is 8 out of 100 times 8 out of 100, which is equal to 64 out of 100. Okay, so what we've got to do now is, instead of leaving it like this, what we've got to do is shrink our sample space, because this is conditional probability. Okay, so this is the chance of her getting a total of 4 calls over the 2 days out of 64 over 100. So what's that going to be? It's 29 over 100 divided by 64 over 100, which is 29 over 100 times 100 over 64, cancel, cancel, 29 out of 64. Okay, so roughly, 0.5 or 50% chance of her receiving a total of 4 phone calls over those 2 days. So watch out for this particular situation here. This is what I call subtle conditional prob. Okay, they haven't said what is the chance of her getting 4 phone calls over these 2 days, given that she did receive phone calls on Monday and Tuesday. So notice that they haven't used the words given that, okay, but that is certainly conditional probability, because they've told you that this thing actually happened. All right, so get stuck into 8F, those particular questions.